Hello students, this is a video about domain and range. This is for those of you who missed any of the lesson days or those of you who just want to review domain and range. As we go through this, I will tell you what to write down and when to write it down. If you would like to write down more than I tell you, you can, but please make sure you get down what I am saying here. The date is a little bit off. We started these notes on 10/26, but if you want to put the date that you are taking these notes, that is fine. All right. So domain. Domain is all the X values whenever we are looking at a graph, a list of values, a mapping, a table of values. So anytime you are dealing with a list of values that are written in ordered pair, or a coordinate plane, domain is always all our X values. When we're looking at a graph, we think of how far left to how far right does our graph go, which we're going to get into some examples of this, but these are just the things you need to think about. And then the range is all the Y values. So the Y axis on the coordinate plane goes up and down. So we're going to ask ourselves, how low to how high does the graph go? And this will help us determine the range values. If you need more time to write this down, pause the video. All right, so if I were to give you the point -2, 3, what would be the domain and what would be the range? Think about what we just talked about. All right, a point is written with the X value first, so our domain value would be -2, and then it's written with the Y value second. So our range would be 3. You don't have to write this down unless you want to. All right, back to the notebook paper. So if I give you this list of values, we have 8, -6, 4, 3, -9, 1. Now X always comes first, Y always comes second. So if we want to list the domain and range of these, our domain is going to be -9, 4, and 8, where our range is going to be our Y values, -6, 3, and 1. Typically, the domain and range is listed from least to greatest, but unless specified, it does not matter what order they go in. Sorry. All right, so anytime you're asked for the domain, it's the first number. Anytime you're asked for the range, it's the second number. All right, so what we just did is called set notation. Set notation is just a set of numbers listed. So another example of set notation, if we want to give the domain of 2, 3, 4, 2, 7, 1, and 8, 5, domain again is all the X values. So it's all the first numbers that are listed in each ordered pair. So our domain for this one would be 2, 4, 7, and 8. When we are writing with set notation, we use the squiggly brackets. Now, if you can't make these perfect, that's okay. Just make sure they looked as best as they can. But we use the squiggly brackets, and then we list out the numbers with commas in between each one. That is set notation. So make sure you do that when you're writing in set notation. All right, leave 1 or 2 extra spaces because we're going to come back to this for a little add-on. So leave 1 or 2 extra spaces, and then you can write down the next thing. All right. 2 other words we need to know for this unit are discrete and continuous graphs. So a discrete graph looks like this. Make sure you draw down an example so we have an example of what these look like. Anytime you have a graph that is discrete, it is distinct or separated. So basically, it's a bunch of dots or points on a graph that are not connected by a line. If they are connected, then we call this a continuous graph. So if a continuous graph is ongoing or unbroken, all right, it may keep going forever or it may have an endpoint on the end, but it's connected. Whereas discrete, they're distinct separated dots that are not connected. So again, make sure you have these words, or if other words make more sense to you, that's fine. There are other words. And then make sure you have a picture or an example of each. All right, so let's look at an example and name the domain and range. This is a discrete graph because it's a bunch of dots. All right, in your notes, I need you to draw this graph, and it needs to be pretty precise. If you would rather have a cutout of this graph, just leave a space for it and ask me for it the next day, and I'll give you a cutout of it. But make sure you know what kind of graph we're talking about here. All right, so if we list the domain is all the x values. So along our x-axis, now we only want to pick the x values that are actually being used in the graph. So this first point we have on 1, this next point is 2, next point is 3, next is 4, then we have a 5, and then we have a 6. So our domain are just going to be those values. We don't have a point on 7, we don't have a point on 8, we don't have a point at 0, -1, -2, all right? It's only the points, the spots that we have points on for the x values. Again, set notation, we have the little squigglies around the numbers with commas in between. All right, and then our range is the y values. So it's how low to how high. So our lowest value is -1. Our next value is 0. Next value is 1. Next value is 2. Then we have 3. And then we skip up here to 6. So our range, again, the squiggly lines, -1, 0, 1, 2, 3, and 6. There are no points at 4 or 5, so we do not list those in our range values. So we only list the values that are actually being used. All right, let's try another example. Again, draw this example down as accurate as you can. So our domain, again, it's our x values. X-axis goes across, it's horizontal. So the x values that are actually being used, we have a 1 here, we have a 2, and we have a 3. 4 is written here, but we don't actually have a point at 4, so we don't include those in our domain. Again, squiggly lines because this is set notation. Then our range values, we have a point at 2, and we have 2 points at 2, and then we have a point at 4. Now, if one of the points is used more than once, we only list them one time in the range, or in the domain if that were to happen as well. If you list it twice, it's not wrong, but when you take a standardized test, it'll only be listed once, so it's a good habit to get into. Again, this is set notation, so we're going to use the squiggly lines on either side of our numbers. All right, so where you left a few spaces below where we were talking about set notation, I want you to add this. We use set notation for discrete graphs, so the graphs that are broken up, a list of points, just like the list of points that I gave you at the beginning, or a mapping. A mapping looks a little bit different, but it's basically a list of points. We've done a couple of them in class. All right, when a graph is continuous, we have two different notations that we could use. We can use inequality notation, or we can use interval notation. In this video, we are going to be using both, so I want you to write inequality notation on one side, interval notation on the other, and then draw a line down the middle. Because I'm going to show you both notations in this video. All right, and then on your paper, make sure you use this for continuous graphs. Remember, the continuous graphs are the ones that are ongoing. All right, so they may have a stopping point, but see how our points are connected here? Whereas our discrete graphs, they were not connected. All right, so there's lots of points in between these 2 points where this line is connected, and that means all those points in there are included in our domain and range. So we can't just list out all the points that are included because there's too many to list. So we're basically just going to give a range of values. Our domain values are still our x values. So for domain on this one, our domain, the furthest to the left it goes is -3. And then the furthest to the right it goes is 2. So in inequality notation for the domain, we're going to have negative 3 is less than or equal to x, because x is our domain values, which is less than or equal to a positive 2. That means our domain can fall anywhere between negative 3 and 2. All right, similarly for our y values, our y values is our range, so it's how low to how high. Well, the lowest our graph goes is a positive 1, and then the highest our graph goes is a 4. So we have our range is 1 is less than or equal to y, because y is our range values, which is less than or equal to 4. Now, interval notation is a little bit different, but we use the same numbers. So it's the same concept as negative 3 to 2, but we use brackets with the parenthesis instead of the inequalities. So we have a bracket here. We have negative 3, comma, 2 with another bracket. Now notice these are boxy brackets. These are not squiggly brackets. Please do not mix these up. And then our range again is similar. It's just use the brackets again. So we have bracket 1, comma 4. But it's the same idea with how low to how high the graph goes. All right, so right underneath we're going to do this one. It says glue this down because in class I gave out these graphs. Again, if you want these graphs, you just have to let me know. All right, inequality notation. Our graph goes all the way from negative 1 to positive 5. So we have negative 1 is less than or equal to x, which is less than or equal to 5. And then our domain, the lowest our circle goes here is negative 3, and it goes all the way up to positive 3. And then just like before with interval notation, we're going to use the boxy brackets, negative 1 to 5. And the range, again, the boxy brackets, negative 3 to 3. All right. Now, this one's a little bit different because we have the arrows here. We don't have a definite end or beginning. So if we're looking at our x values, since we have these arrows here, they're going to go on and on and on and keep getting wider and wider and wider and wider. So our domain here is going to be using the infinity sign. So we have negative infinity is less than, we cannot have equal to infinity, so it's just less than x, which is less than infinity, because it's going to keep going and going in the positive direction as well. Now our range value, how low to how high, well the lowest our values go is 0. So we have 0, and it can be equal to 0. And then y is less than infinity, because it's going to keep going up and up and up and up and up. But we can't be equal to infinity. Interval notation is very similar. When it can't be equal to, over here, we use the curvy parentheses. So not the squiggly ones, but the curved. And then we still use a bracket for 0 because it can be equal to 0, and then the curved one for infinity. All right, this one again, we have the arrows. So our domain is going to be negative infinity because it's going to keep going and going and going to the left, to the left, to the left. And then it's going to keep going to the right, to the right, to the right. So we have positive infinity. And then our range is going to keep getting lower and lower and lower and higher and higher and higher. And again, we have the parentheses because it can't be equal to infinity. All right, so set notation, we use the squiggly lines. Interval notation, if it's an exact number, we use the brackets, or inequality, we have the equal sign. Or if it can't be an exact number, then it's interval notation, we have the parentheses. Whoops, sorry. Or inequality notation, we do not have the equal sign underneath. All right, I know that was a lot in one sitting, so make sure you go back and re-listen to any part that you got confused on, or email me or ask questions tomorrow in class.